You may be wondering what we just did right there. That was a quick check on the VBAT line to see if there was any current leakage or a short circuit on the VBAT section. But from our readings on the multimeter, it shows that everything is practically okay from the VBAT section. Follow me as I repair this Samsung Galaxy A60, which was given to me by another phone technician. He said the client brought the phone and said he had a screen problem, so he tried to replace the screen, but there was no display or the phone was not turning on, so he brought it for me to check. So after checking the VBAT, I had to plug it to the DC machine to see if there was any auto consumption, and right there we got an auto consumption of 2 amps, full 2 amps that I set for the DC power machine. Now what this tells us is this PCB has a short on the secondary rail, that is the VPH line or any other line that is connected to the power rail that can power up this phone. So after checking that, with all this knowledge, knowing that if the short was not coming from the VBAT section, it has to come from the secondary section. The only way we can easily deduce this is because the multimeter is limited to just the VBAT section, that is the primary section of the PCB. It cannot read shorts after the VBAT section. So in order to get to know that this PCB was shorting, we connected to the DC power supply, because the DC power supply reads both the VBAT and the secondary power rail, which is the VPH. So to understand what we were doing, I had to head to the schematic diagram, which is very important for any phone technician, and head to the charger data so as to understand where the circuits are found on the phone to make the troubleshooting easy. So if you take a look right there, we have the power section, that is the OVP, over voltage protection IC, and current leaves from the VBus, that is the charging section, then passes through the VBus and passes through the OVP, then gets into the charging IC. From there it generates the VPH line. That's basic knowledge any mobile phone technician should know. So the charging IC has 2 ways of receiving current. It's either from the VBAT direct, that is the battery terminal, or through the VBus, which has to pass through the OVP, that is the over voltage protection IC, before getting into the charging IC. And on this Samsung Galaxy A60, we realized that the charging IC was integrated with the power manager IC, so it's really a tough one. So after checking where those components were present on the PCB, I had to cut off this shield from this area. I was trying to make a very short video, but due to the fact that the shot was kind of complicated, the video could not be shot, so I just had to cut off this area of the shield to see if I would just get the shot from there, because when I connected to the DC power machine, I was getting some heat from this area, so I had to narrow down the troubleshooting to this area. So I just had to peel off the shield gradually. If you want to do advanced troubleshooting and repairs like this, you should contact my mentor Sergis Mike Tech, or get his block diagram master book, which is a book for all mobile phone technicians. He is planning on hosting a physical class very soon, so you can contact him through the numbers I'll leave at the end of the video. On checking this section, seeing the power manager IC, I thought maybe the power manager IC was bulging out, because if you take a look at the stuff that was covering the power manager IC, it was really hanging out. So I thought maybe the power manager IC had a problem, but the power manager IC was okay. It was just a protective coat around it. So now I had to go back to the schematic diagram and head to the bit mapping. So when I click on the charging the VBAT section, you see that the current goes into the charging IC, which is the same time the power manager IC. And if I click on that inductor right there beside the power manager IC and the charging IC, you see that all these other areas beeping red are connected to the VPH line. But the shocking thing is this short was not coming from the VPH line, it was coming from another section that is linked to this VPH line, not directly but indirectly. So if we take a look, you see all these sections that are beeping red are the VPH line. So we have to start checking all these connections to see if there was voltage present. So I had to start from the power manager IC area. If you check, that is a VPH inductor. The voltage was okay, that is a good voltage reading for the VPH line. So I had to come down to this other section and check this other inductor right here. If you take a look, we had a good reading. Then shockingly, these three capacitors right here were beeping. I'm like, these capacitors are not connected to the power rail, but how come are they beeping? And if that's where the problem is coming from, how can it shut down this PCB from not turning on? So I had to head back to the bitmap and then check how those capacitors were connected. On checking, I realized those three capacitors were connected to that IC right beside there, and the inductor beside that IC is connected to the VPH line. So it's possible if these three capacitors or one of them was shorting, it could affect this other this VPH line through this IC that they are both linked to. So I had to check every other circuit that was available around there and check to see what was going on. So right now I had to spray my short powder first and then try to connect to the DC machine, since we first of all connected and saw that there was an area heating up on the PCB. So I had to spray the short powder, connect to the DC power machine to see which component will melt up the rosin flux we just applied on the PCB. Shockingly, when I connected, you realize that that area was practically heating up, but not that much, because the capacitors that I found out later that was shorting on this PCB were small capacitors. So after trying to feel with my hands, I realized something, that the power manager and charging IC, it was because they are both integrated, so I'll just call it charging IC and power manager IC. It was the only component that was melting off the rosin flux that was applied on it. So I had to test the other section behind to see if maybe there was heat coming up from that section. At this point in time, I had to peel off the shield completely because I had to get full access to that area, because on checking the bit mapping, we realized that the rail that was there had to extend right up at the other section. Unfortunately, while I was cutting off those shields, it seems like these two capacitors here, they had a breach, so I had to try to clear off the breach, so it should not be shorting while it wasn't supposed to. So I just had to clear off these two capacitors from not linking to each other. Then on testing, you realize those three capacitors right there, these two beside this inductor and the other two were beeping. So I just had to go ahead and test the PCB, check other sections and so on, if I could get any short from anywhere, because my focus was on the VPH line because I knew this was a secondary short. But you see those three capacitors I just tested and the two inductors that were linked to, they were all shorting. So I had to just, as someone that does board repair, you just have to check those capacitors and components at times, because they can be shorting elsewhere and connected in one way or the other, thus affecting the VPH line. So at the end of this video, you understand what I'm trying to say. So I was still testing to see if I could get any other shorting components that were linked to that circuit. So I even had to turn behind and check those were the inputs for the CPU, and I knew the short could not be coming from there, but I just had to check, curiosity and just being sure. even the other circuit right down there. I just had to check everywhere on the PCB. Now when you're working on board mobile phone repair and doing advanced troubleshooting, you have to be very patient and you have to work at a convenient time that is convenient for you. So while working, you don't get disturbances from maybe people around and so on, questions. So you just have to concentrate. So now I had to head back to the schematic diagram right there and then try to see any other components that were connected to those beeping capacitors. If you see, when I click right there, those two capacitors were connected to this inductor, as you can see from the bit mapping, where they were connected only to those two inductors. And when I click on the other inductor right, the other shorting capacitor right here, you realize that it was connected to that inductor and another component besides the power manager and charging IC. So at this point I could understand that, okay, if the short is coming from here, let me try to inject the voltage, because those three capacitors plus the other three capacitors we saw there on the other circuits were all shorting. So I had to figure out a way to try and inject voltage from this section to see which component is going to consume the current or heat up, so we know how to troubleshoot further. Little did I know the solution was right in front of me, but I was just trying to troubleshoot thoroughly. So I was just trying to go through, check every other component and every other section that is connected to that line. If you see, I was going about checking the other sections that I saw that was connected to those lines that were shorting. So quickly I had to spray my rosin flux and try to inject the voltage on those shorting capacitors. I had to apply the rosin flux on all the other circuits that I saw that were connected to that particular shorting capacitors. Alright, so now I had to consult the bit mapping once more to be practically sure of where I'm going to inject the voltage, or the areas I'm going to be expecting a reaction if the short was truly from that capacitor or not something else shorting it. So we're supposed to be expecting reaction from this area right here, the other area beeping up right there. Okay, so I had to quickly spray up this other area because I realized it was also connected to the shorting capacitors. The circuit was connected to it. So quickly I had to take my clip on my alligator clips and connect one of the terminals from the DC power machine to my multimeter probes. So just consulting once more, I had to inject from the first shorting capacitor that I found, and shockingly the capacitor melt off the rosin flux that was applied on it. And I'm like, coincidentally, at times it's possible that the first capacitor that you inject the voltage from can be the shorting component. So the only thing I have to do was to inject from another capacitor that was still shorting to see if we'll get the reaction from that same capacitor. But shockingly, the second capacitor I injected the voltage from, it was still melting off, and at this time I was not getting any heat on the PCB. So I had to test the remaining capacitor, because remember there were 3 shorting capacitors from that area. So I had to regulate the voltages again and said maybe the voltage and the amps I said was too high, so let me try to reduce it a bit and see if we'll get the reaction. So I had to inject again and see if the reaction will be the same. And if you notice right there, since I had reduced the amps and the voltage on the DC power machine, the capacitor was still melting up but slowly. So I had to increase the amps on the DC machine for faster reaction. And if you see right there, it was the same component that was heating up. I had to check behind the other component that we applied the rosin flux to see if there was any reaction, but there was no reaction. So quickly I had to spray this area again. It was getting a bit confusing, but I had to keep on troubleshooting, because you have to fully understand what you are doing on a PCB before you can work successfully. You have to know how these circuits work. Alright, so once more again, now I had to connect again to the DC machine to see where the reaction will occur, since I have sprayed the whole section. So when I connected to the DC machine, I felt the heat coming from that section, but the reason why it could not reveal itself is because those capacitors that were shorting around, they were smaller capacitors. So current coming in from the DC machine was diverted into the charging IC instead, because I think that is the only component that could handle the voltage that was coming from that section. So I just had to keep on testing and trying to feel if there was heat coming up from any area from there, and there was no reaction. So I also had to increase the amps on the DC power machine, and if you realize there, it was still the power and charging IC that was heating up. I was still not convinced that the charging IC or the power manager IC has a problem. I was fully aware that it would be coming from one of those capacitors, but the only problem I had was I had not yet injected the voltage on the real position or the real component that I was supposed to inject. Then I said, but these capacitors are linked directly to this inductor, so why don't I inject maybe from the inductor and see the reaction? Then I just had to check again, test the capacitors once more to see if the short was still there, because at some point in time it gets confusing. So now I had to spray the short powder once more, but now injecting from the inductor. So injecting from the inductor, that is the coil around the power manager IC that was connected to those capacitors, we realized that the short was coming from that capacitor. You understand what I was saying now? That coincidentally, the first component you inject the voltage from, the shorting circuit, might be the shorting component itself, just like we have seen now. I was injecting voltage from that capacitor, it was melting off, and I thought maybe the amps I set and the voltage was too high for the capacitor, but later on troubleshooting further, we realized that it was the component was actually shorting. That's why it had to heat up the first component. So I had to zoom in for you guys to see, then inject the voltage again from the same inductor or coil, as you may know, to see if the reaction will still be the same. Now you see the reaction was the same. So we concluded, now I can conclusively say that this capacitor was shorting and could be part of the problem that the PCB was not turning on. So I had to do it again the third time, just for educational purpose, so you fully understand what was going on. So when I inject again, it was still the same component that heated up. So at this point in time, the next thing to do was only to remove that capacitor and then check if the voltage was present or if the short was gone. Alright, so heading back to the circuit on the bit mapping, you will see that that is the capacitor that was shorting right there, and they were supposed to be two capacitors, but because maybe for model reason one other capacitor was not present, but the position was provided, so it's just manufacturer's reasons. I cannot really tell, but it shows that it has no role to play there and the others can do its work. So next I had to scrape out the capacitor that was shorting. I really avoid using heat to remove these components, especially when they are around ICs, because you can leave from maybe a shorting problem into an open circuit problem, whereas you need to start reballing ICs and so on, which is really time consuming. So checking the capacitor just to confirm, you see that it was still shorting while on the ground. So now I have to take readings from the inductor, you see that the reading was okay now, even from the shorted part. But shockingly, the other inductor beside and the two other capacitors were still shorting. Now you get to understand why they were still shorting, because those two capacitors also, one of them could be shorting and it's linked directly to that inductor, but this inductor and these other components are not connected to the other area where we first of all remove the short. They are not linked in any way. That's why the short were separate. So now, since we already injected from the inductor and saw the reaction on that capacitor, I had to inject this other circuit from the inductor itself. And I had to inject from this inductor to see where the reaction would show off, and it was melting up because at this time I had reduced the amps. Doing this was to avoid damaging maybe this IC. So I had to check the other circuit if there was any reaction from there as I injected from the other inductor, but there was no reaction. So I had to check again if maybe those two capacitors had been bridged together, but nothing was bridged. So just rechecking to see if the short was still there and the other inductor had voltage, which means it was okay. I had to go again to check the bit mapping to understand how that circuit works. You realize that if you see what I was talking about, you see that section is not connected to the other inductor that will first of all remove the short beside. It is connected to other components around the other power manager IC up and another circuit right up there. So I just had to take my multimeter to confirm all those circuits that I saw, if those capacitors were shorting, to confirm that they are all linked together. If you check there, that was a short, right? And we headed to the other circuit right there. There was also another short from there. So this confirming that the rail was totally linked to it. So now at this juncture, I had to increase the voltage and amps on the DC power supply, and then try to inject again from the same inductor to see the reaction. Shockingly, this time the first capacitor we injected the voltage from was the first component to heat up, and I'm like, wow, how can we have two or more capacitors shorting on the same area? It's my first time of seeing this since I started troubleshooting, but we get to learn every day. This was like more of an educational video for me as well. So now I had to regulate the amp so the component will heat up again faster, and we still realize that was the capacitor that was shorting, because it was the first component to heat up right there. So just spraying again one more time, then injecting the voltage to be practically sure that it was the capacitor that was heating up. And when I inject the voltage, we realize that it was still the same component that was heating up. Now it was heating up slowly because I had reduced the amps on the DC power machine to be practically sure that it was a shorting component. Just to zoom in, just to get a zoom view again. You see how it was heating up. So we can now conclusively say that that other capacitor was also shorting. So now next thing was to remove the capacitor and then check if the values were back or not, or we still had a short. So it was really a long troubleshooting. If not of the fact that I edited this video, it would have been a very long video, because most people rarely watch technical videos up to the end. They just scroll through to see what you did at the end for the phone to turn on. Troubleshooting is very disturbing, because you don't always have the same result or the same problem on every PCB. So you have to understand what is done to solve the problem, not the solution at the end. You just it's like doing copied work. You just head to the solution without knowing how the process was carried out. So after that, I have to now check if the voltage was back, but shockingly there was still a short on that line. You understand what I was saying now? There was still a short on that line. So quickly, since I already know that, okay, I had to inject from the inductor, I just had to respray the area and then inject the voltage again and see if that other capacitor there will still heat up. And then I'll say, okay, that's our shorting guy. So I had to inject, and you see the capacitor also heated up, just confirming our suspicion from later. So I have to spray again, then inject from the same inductor, and they will still have the same reaction. So at this point, there was nothing else left to do, just to scrape it off, then check for values. Remember, each time you remove a capacitor or a shorting component, you make sure you test the capacitor on your diode mode to see if there's a beep on both ends to confirm that there is. It was practically the shorting component. And after that, you head back to the PCB and check if the values are back on that line. If you check now, we had a value instead of a short, we now had a value of 363. That was a very good reading for that line. So now, just to confirm that maybe the short was gone, since the DC supply was the one that detected the short for us, I had to just connect to the DC power supply and then check if there was still any auto current consumption. And when I connected, I realized there was no more shorting component around. There was no more. When I connected, there was still an auto current draw of 2 amps, and I had to check to see if there was any shorting component or heating up area. And right there, something burned my hand quickly, and I was like, oh, this was the area. Another short was coming from this area. If you remember, this was the first circuit that we discovered there was a short circuit there. Those 3 capacitors were shorting, and I explained that those 3 capacitors were linked to that small circuit right there and that IC. So if one of those capacitors was shorting, it could pass through the IC and then affect the inductor, which was linked directly to the VPH line. So that could be the reason that the phone could not turn on. Because if you check, those 3 capacitors are connected only to themselves, but now they both share the same IC with that inductor that is connected to the VPH. So that could be the reason. So the only thing to do was to inject voltage on one of those capacitors to see where we'll get the reaction. Remember, we have already removed 3 shorting capacitors. Now this was going to be the 4th capacitor on a single PCB. It was my first time seeing this, so I had to inject from here, and we have got a reaction from the capacitor that was in the middle. And I just had to spray again. I always like to confirm shorts by injecting from multiple locations. So since those 3 capacitors are connected, the first capacitor made the second one to short when I injected the voltage. So I'll now inject from the other capacitor to see if we'll have the reaction on the same component that was melting off our rosin flux. So we really confirm that, okay, this was the shorting component, because they are both connected. So if one of them is shorting, it has the right to affect all the 3. So injecting from any of those capacitors will give us the same result on the shorting component. So just to get the confirmation right there, that capacitor was shorting. So I had to remove the capacitor. You have to be gentle not to scratch off the PCB or pull off the other component beside. So you have to remove, and like always, check on ground if it's shorting, and then go back on your PCB, check if the voltages were present. Alright, so after checking the capacitor that was shorting, I had to go back now, and if you realize now we had voltage on all those capacitors instead of a short. So this tells me at this time that the short was completely gone from that area. So now, just to confirm, we have to plug it back into our DC power machine to see if there is still an auto current consumption. Now when I plug it this time, I realized that there was no more auto current consumption. As you can see from the DC machine right there, there was no auto current consumption, which means that the short on this PCB was totally gone. So now the next thing to do was we only had to clean off the PCB and connect again to the DC power machine, then try to trigger from the DC power machine before putting into its casing. So I had to connect to the DC power machine and then check the values on the trigger key, that is the power on key, to see if voltage was present before I can trigger on the DC machine to know if the phone is actually turning on before putting it into the casing. Not to rush, you have to be gradual and precise in what you're doing. So I was trying to contact the power key right there to see the readings on our DC power machine. So if you take a look right there, it was ending at 1 point something amp. That was because I reduced the amperes on the DC machine before injecting the voltage. That's why it could not pass that level, so I had to increase the amps to about 2 amps. So it was first of all consuming just 0 point, and now when I click on the power key, you saw that we had a very good reading, climbing up to 600, 700, 500, 400, 300. That should tell, and up to 1 point something, which tells me that the PCB is fully booting up right now. So I had to disconnect, clean the PCB, and then put back in its casing, in its chassis, to power on fully and see if we have a logo or if the screen was still okay. Remember, the phone was from another technician who said he had already removed the screen to test another, so I was doubting if the screen was still okay, but we just had to connect everything together and then try to test. So I took my time trying to fit in everything, battery and so on, putting the motherboard in place, and then try now to connect to see if we have good values and readings and boot logo as well. So if you have watched this video right up to this extent, I really do appreciate you. Don't forget to like, subscribe, share and comment, so that each time I drop an educative video like this, you'll be the first to be notified. So now I was done putting everything back into its casing. I had to connect now to the amp charger to see if we'll get any reading on the amp charger. If you take a look right there, we're getting a reading of 5.18 volt and 1.6 amps charging, which means the phone was fully okay. And if you check on the screen right there, we had a charging logo right there. That's the circuit we were working on. That's where we remove the 3 shots, and the other side is where we remove the single shot. So now the next thing was just to power on the PCB to see if it's going to fully boot up. So I had to, since I don't yet have a camera that's set up to monitor my DC machine, I had to keep my phone, short circuit the power key for the phone to switch on before I can record. So it's really cumbersome, but with time I'll have all the cameras set up so I don't get to touch this area and touch that area. So if you take a look right there, we had our boot logo right there. The phone was booting up. This was a very happy moment for me. Removing 4 shots on a single PCB, I did not know this phone could still turn on. But the only reason that I'm sure the phone could turn on was because all those components were not connected directly to the VPH line. They were connected to other components that were linked to the VPH line. So the phone booted up right there. That was, you can see the screen block, and I had to test if the screen was working, and everything was working in place. So that was another successful troubleshooting, guys. Like I said, you can contact Sergis Mic Tech if you want to be an advanced and pro troubleshooting technician like I'm doing right now. Every knowledge I have is from him. Thanks to him. That's me right there. Thank you for watching right up to this extent. Stay tuned for more content.